Hey folks, Ms. Gosling here. In this video, you are going to learn about momentum. By the end of the video, you will be able to calculate momentum and solve some similar related problems. So with no further ado, let's go ahead and get started. So we're going to define momentum as a measurement of how easy it is to change an object's velocity. And more importantly, we are going to define momentum, P, as being equal to mass times our velocity, V. And you might notice that both P and V, momentum and velocity, are bolded, and that is to represent the fact that they are both vectors. So now that you know what momentum is, let's go ahead and solve a couple of example momentum problems. So example 1, a 0.015 kilogram baseball is traveling at 45 meters per second. What is its momentum? So following our usual method of solving problems, our givens are the mass of the baseball and the velocity of the baseball. And of course, our unknown is our momentum. Thus, P equals question mark. And we are, of course, going to use our momentum equation to solve this problem. So we're going to say P is equal to m times V. And moving forward to our sub and solve stage, we can write that P is equal to 0.015 times 45, thus giving us a momentum of 0.675 or 0.68 kilograms times meters divided by seconds. You'll notice here we don't have a specific unit for momentum, we just use the units of mass times the units for velocity. Moving forward to a second example. In this example, we have a 2.5 kilogram bowling ball with a momentum of 10 kilograms, and we defined its velocity. So again, we're going to go ahead and start by listing out our givens, and we'll find when we know that our mass is going to be 2.5 kilograms, focusing of course on our units to know that it's mass. And we also know that our momentum is 10 kilograms meters per second. Meaning that and now that we've listed our givens, we are ready to go ahead and talk about our unknown, which in this case is going to be our velocity, V. Using our momentum equation, we'll write P is equal to m times V, momentum is equal to mass times velocity. Thus, velocity is equal to momentum divided by mass. And moving forward to our sub and solve stage, we can write then that our velocity is equal to our momentum of 10 divided by our mass of 2.5, thus leaving us with a velocity of 4 meters per second. And there you have it, guys. In this problem, you've learned how to use the momentum equation to solve for things that are not momentum. Moving on to one last example problem. If the mass of an object doubles, what would happen to its momentum? So in this case, we are assuming that our velocity stays the same. So say that our mass is an initial momentum pi, and that is going to be equal to m times v. What we want to do is figure out what is our final momentum with respect to our initial momentum. So we know that our final momentum is equal to m final times v, or 2m times v. Thus, our momentum, our final momentum, is equal to 2 times our initial momentum. So if we double the mass of an object, the object's momentum doubles. And so there you guys can see an example of a less quantitative problem, a problem that makes you think about the question. So with that, let's go ahead and move forward to our takeaways. So our first takeaway is that momentum is equal to mass times velocity. And our second takeaway is that you can solve momentum problems using momentum is equal to mass times velocity. And of course, emphasizing the fact that both momentum and velocity are vectors, so our direction does matter. One example of this, if something changes direction, so it's going to the right and then it switches and starts moving left, that is a greater change in momentum than if it is moving right and then stops. So with that, you now know how to solve momentum problems, both quantitative and theoretical. So now it is your turn to try this out on your own. Best of luck and happy solving.